Welcome everybody to Dallas Personal Robotics Group Robot Builders Night Virtual for Tuesday, July 21st, 2026. Tonight we will do our normal roundtable presentations of robot projects and then open the floor up for any questions. Reminder, the club business, Robo Columbus 2026 is, I think, just less than 4 months until the event. Are you ready? Get the wheels on the ground and get them moving. Time is coming up quick. Other club business, DPRG just went to Moonday last Saturday, and Paul will give us an update on how it went.
Yeah, so let me just share this window. So we had a U-shaped table booth. We had this table and then this row of robots down the side, as far as Eric, and then Trisha's team was off on the far end, and Kareen's team was off to the on the near end to the right. And going the wrong way. Yeah, so there's Doug standing at Kareen's team, and they had a robot that they had spinning around, and they were having all kinds of fun with it. You know, throwing at balls and catching them when it threw them back at them, and you know, zipping it around people, and people were really enjoying it. They were having a good time, and they were entertaining everybody. So they were doing great. We had Roby, who was not working well. And he'd like spot someone's face and then he'd freeze for several minutes and they'd walk off. And we had Mark's float. Unfortunately, Doug blew up the tow robot before the night before the show, so we couldn't have it doing the line following. And also, unfortunately, the second of the mobile displays on top of the float died the night before, so it was just a static display. And then Mike had his robot, which attracted a good amount of attention, and then Doug had a whole table to himself with like big robots, legged robots, small robots, all kinds of stuff. And then the Vex robotics people behind us. So there's Doug's stuff. The Vex guys were like super happy. They were printing off keychains, so people could personalize their keychain with their name, and then they'd print them a keychain. So and they had some earrings as well. That was cute. And they had their like big banner over them, and then the Vex team, sharp young group, and they and Iron Rain were busy all day. They pretty much had visitors coming to talk to them the whole time, and Trish managed to snag 3 judges out of the visitors, so she was real happy with it. So it was a good outcome for the Vex Robotics group. And so they didn't actually have live displays, but we were giving away the mouse pads, and I think we gave them all away. So yeah, more of the display, a shot from up above looking down. Yeah, so that's that. So that was Moonday. It was fun. It was fun getting out and doing that thing again, and hadn't done that in many years. So enjoyed it. And thank you to we had 5 DPRG folks, not counting Trish and her students and the Iron Rain team. So we had. I want to say we had, and Trisha's team changed out half of their team midday, so they had like 4 students there for the morning, and then a different 4 for the afternoon. So we had like probably a dozen people in our around our U-shaped table. So it was a good show. So that's all I had.
Thanks for that update, Paul. And up next for presenters, we have Paul.
Okay.
Well,
so
he's gonna give update on. Is this one on Roby?
Yeah. I can do. Well, no. Let me do Moberry first.
Okay.
And so I'm going to try once more to turn this camera around, because it just should be possible. Just should be possible. Let me see how I can do that.
This is where Roby says, "Bring me my legs and my arm."
Yeah. I'm not sure.
Scarecrow, the Wizard of Oz. They took my legs and they threw them over there.
And that's where. Okay. Good idea.
Okay.
Star Wars.
Well,
From
I'll see if I can.
Wizard of Oz.
Okay, I'm going to give up on this and see if hopefully the webcam will reach around the corner. Yeah, it will. Okay. Good. Okay, so let me just share then. So this is now up to the level of what I ran at Robo Columbus.
So did you mean you chose like 3 or 4 waypoints and it went between the
Yep.
3 or 4 waypoints?
Yep. So so here's my, can you guys see this?
Yeah.
The command. Maybe I need to blow it up a bit. Okay, so RR Mover is the client. It's telling it to drive waypoints. These 3 waypoints in order. These are offsets from the origin, local origin. Then rotate using odometry 90 degrees. Kareem did my rotation module, so thank you to him. 9 degrees at forward speed 0.2. So this results in driving an arc. And the reason for driving an arc is mowers don't do well swinging that front mower bay around through 180 degrees on grass. They just don't have enough traction on the wheels to do that. So I'm doing a K-turn here. So he rotates 90 degrees, then he moves backwards a meter, then he rotates another 90 degrees, then he drives the waypoints in reverse. So we'll see. I've found that I'm rather good at writing buggy software, so we'll see if this actually works. I'll hit enter, and then I'll switch windows to the action server. And can someone pin me?
It looks like they already did.
So hopefully there he goes. So
yep.
It's off he goes. He's heading for his first waypoint. Now he's heading off for the second waypoint, which is like up around the middle of the corner in the driveway. His steering, I'm going to have to put a PID loop in the steering. So sorry for the
Does it oscillate or something?
What?
Does it oscillate or hunt
Yeah,
back and
yeah. You can't really see it, I'm afraid. But yeah, it's wiggling backwards and forwards real badly. And now it's getting close to the third waypoint. If I can, where I wish I had my phone was working, because I could zoom in. Okay, so now he's doing his K turn. Slowly swinging around. Much tuning is needed. There's the backward motion. And now he's winding his wandering way back down the driveway to the 3 waypoints in reverse.
So the reason you're not outside is because it's 104 degrees.
Yeah, yep. That would be it. And I think he just
The
acquired.
robot has to deal with it. Yeah.
He's quite happy out there. I'm not, though.
Okay.
And yeah, he's achieved his final waypoint. So anyway, that's Moberry doing driving waypoints and rotating and doing all the things that he did that Mobot did in for a Robo Columbus. So and he's using GPS for navigation, RTK GPS. So that's significant. It's using that LC29H
L5?
the $73 receiver. I've had all kinds of problems with RTK to go that I gave up on it, and I'm now just feeding corrections locally over Wi-Fi. Maybe they'll fix it, maybe they won't, but I'm not dependent on them anymore.
Mm-hmm.
So that's
How close was it to the? Did it return to the origin point?
yeah, it did. It's sort of facing.
Okay.
It's facing in the other direction because I didn't have it do a U-turn. But yeah, he's back pretty much at his starting point within a meter or so.
Okay. Well, congratulations. Give you a gold star for that.
Yeah. Yay!
I think it warrants a gold star.
Yeah, he's like really driving, so that's pretty exciting. Need some tuning and the whereas for Robo Columbus, I was using the ZF9P RTK GPS receiver and getting corrections, I think 5 or 10 times a second. I'm sorry, getting fixes 5 or 10 times a second. The LC29H is only giving me corrections 1 time a second. So his position feedback is very stepwise, and so that doesn't help the control system at all. And so I'm going to. There's a new package out called Fusion Core that is a new ROS package that integrates GPS and IMU and odometry to produce hopefully a much more accurate fix. So that's probably the next thing I'll do is get that to try and get a better that and get a PID loop in the steering so that he drives better. Let's see. Now.
Well, that's good, Paul.
Yeah, and then boy, if I could figure out how to maybe I'll see if I can figure out how to get my phone working after a while. But I wanted to I think a number of people on this call haven't seen Roby, so I thought I'd maybe do a brief show and tell over like how he's built and what he does. But since the show, I've been working on him, and I just put in ramping steppers. So I'm sending a command from the keyboard to raise his head, lower it, and then pan sideways. And but what we were actually trying to show at the show, albeit not very successfully, was okay. So one of the things we did for the show was to put a Raspberry Pi in his belly, and hook the webcam that's in his head up to the Raspberry Pi, and so I just got the I just got ramping speed control working, and so I'm going to share the desktop of the Raspberry Pi. That one, and okay, and I put the Arduino IDE on the Raspberry Pi, so we can build and reprogram the Arduinos directly from the Raspberry Pi, and I'm remote desktoped into the Raspberry Pi here, and I'm going to start up the face tracker, and so that issues a center command, and then displays the video from the camera, and then starts looking for faces, and got a little bit of a bug in it where it will go to one stop and then not start scanning back for a while, but now it's scanning back, and so you should find him, see me, and then center hopefully.
Gotcha.
Got it.
Then he starts rotating his wrist and his arm. It's a bit of a mystery as to why what causes the arm motions to happen, but he'll actually track my face as I move around.
Better watch out. That thing might lure you in and give you a smack with his arm or something.
Yeah.
Right?
False sense of security.
just stay at arm's length. There you go.
That is working pretty good.
Maybe you could get it to say, "Would you like a piece of candy?"
Actually, that would be cool. We fill the arm with candy and have it dispense one. And click, there you go, candy. Click.
Yep.
And
Lynch.
so anyway, that's what we were trying to show on Saturday. We were not very successful because we didn't have. It was freezing, and Mark had fixed it, but I didn't know that. So anyway, that was a sad story from.
So the pan motor, the biggest change you made was the ramping, huh?
Yeah.
Okay.
I changed multi-stepper light out to, and yeah, so that's something I wanted to talk a little bit about. It likes to recognize things that aren't faces.
You might have an invisible friend in the room with you.
Right?
Maybe it thinks those two squares are eyes or something, you know.
Yeah. It's
Interesting.
It's hallucinating.
yeah.
I still gave it a gold star for tracking you fairly well there.
Yeah, thinks the back of my head is, it's not. It thinks a lot of things that are faces that aren't. But anyway, it's just panning around, looking for someone for a face to latch onto, and then center in the frame, and then start his arm waving motion. So one of the things
Could be one eye and a nose, you know.
I put in an acceleration, stepper's acceleration setting, which is defined by time to max speed. It's set to 1.0 seconds to reach max speed at the moment, and if I give it the command to do the center operation, you watch its pan speed, it's actually got a pretty reasonable pan speed.
Yeah, compared to what it was, yeah.
So
That's pretty quick.
we were talking about maybe we need a bigger motor on the pan, but it actually works. It actually worked reasonably with the NEMA 11 motor if you ramp it. So anyway, it's not centering at the moment, and
Is the soft electronic stops working? Or
I don't know about them, so I'm
okay,
gonna say
because I like on the Arduino code, if you pull up the plot, it'll show you every time it triggers.
oh, okay. So anyway, what I want to demonstrate is if I change this to change the time to max speed to 0.5, and do the same thing down here for the pan, 0.5, and then program the Arduino. So this is just so nice, being able to just like edit and reprogram right off the Pi. Okay, so now I'll start up my head UI and do and you can hopefully you can see that it's oscillating when I tell it to take a step. And so the difference there is just ramp rate.
Okay.
And that was one of the things that was giving us fits really before the show and at the show. And it happens on the it oscillates on the tilt as well. Not quite as badly, but you can see that it is oscillating. And what's causing that is there's it's a reasonably heavy head. It's 53 ounces, about 3 pounds. And most of the mass is out at a distance of 6 inches from the
Axis.
the axis. So it's got about 1.5 foot pounds of torque. And when you ask it to step, the way the old code was working was it would just take off at a constant speed of 50 steps per second. And so, the motor would start going do, 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 do. And meanwhile, the head is lagging. So the motor goes do, 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 and then the head starts to experience the spring tension and starts to twist. Meanwhile, the motor stops, the head overshoots, and then sort of like swings back. So it resonates. Setting the max time to max to 1.0 gives you a slower ramp where it doesn't get to do that oscillation. Okay, so
So the library in the Arduino actually implements the acceleration, not in the driver, right? Not the hardware driver.
correct. Yes. So I used Excel Stepper, which was a drop-in, well, not quite drop-in, but drop-in with a little bit of tweaking of the API in replacement for multi-stepper. But it works kind of the same way. You tell it the max speed and acceleration ramp you want, and then you call it in loop and call its run method, and it sends out a pulse when it's time to send the next pulse, and does the ramping calculations to know when to send the next step pulse.
Does it also ramp down?
Yeah, ramps up and down.
Up and down, okay.
And
yeah, the Excel stepper is actually a pretty sophisticated little driver. It works really well.
yeah, I got to say, I'm impressed. So let me just put that back to 1.5. I mean, back to 1.0, and it never actually gets to full speed when it's just doing those little steps. Okay, we'll reprogram that guy. When it's panning around or tracking to center a face, it never actually gets to come on. Don't do that. I had another app owning the serial port, and so now Arduino has gone crazy.
But yeah, bring up the plotter.
Okay.
Under tools.
I don't think 1.8 has the plotter, does it? Or does it?
Oh no. It'd be under
Mine
tools.
does on
if it
the
did.
Raspberry Pi.
Tools,
There it
yeah,
is.
serial plotters.
Serial mod-
Okay.
Then if you do a center, you'll see if it's hitting if it's detecting the end stops.
Oh, okay. So do I need to start the serial monitor, or how would I tell it to center?
I think it's just. Oh,
I don't think I
oh,
can
it's
do
just
that,
sending the
right?
data.
Because it's spitting out data out of the using the serial port, so I can't give it the C command.
Oh, huh? Oh,
Yeah, you can just put C in the little bar below on the serial plotter.
Oh,
Yeah.
And hit
okay.
capital C,
Wow, didn't know you could do that.
capital C. Yeah.
I made it accept upper and lowercase
Okay.
like the body Arduino.
Okay.
Oh, wow. Something's out of scale.
Yeah, it's
Okay.
not scaling right.
Yeah. But you can see the little things there. That's why it looks weird. It's just that the scale's off. It always auto scaled for me.
Huh.
It should auto scale though.
But you can see the little blips.
Yeah.
I'm not sure how you change the scale.
Maybe if I relaunch it. It's cool. I've never actually done this, so I'll have to wonder how that works. What's it taking as
The serial monitor should show you the data.
Oh, this looks like it's only showing you two colors up there in the top.
Yeah,
left.
one's a pan, one's a tilt end switch.
Okay.
Yeah, or end detect.
so it's just when you give it the C, it just prints out that like 0, 0, 0, just like a pair of zeros, which are
right. But when it hits the switch, it prints out a 1.
Yeah. Right.
For plotting. Yeah.
Okay.
Wow. Yeah. So it's detecting them pretty good. It's just doing 2 for some reason. But yeah.
Mhm.
Oh, how about that? I didn't know you could do that. Cool.
Seems like it's not responding to them, but oh well. But that's pretty cool. This seems to work better with the new driver.
Yeah, it really does. It doesn't skip steps. Like when I do a Santa command with the old driver, you'd hear it just like miss a couple of steps at the outset, and it doesn't do that anymore. It just like ramps up smoothly. It's really pretty nice.
Did you change the drive current or anything? Or
No, I didn't.
okay.
I experimented with the drive current, and actually I wanted to ask you about that Mark D, because I find that it's hardly pumping any current into either of the steppers. It's only pumping, well, best I could measure with my clip-on ammeter, maybe 0.3 amps into the NEMA 17 tilt motor, and a lot less than that, maybe 100 milliamps into the pan motor.
Yeah, but that's a peak current, and it's pulses with long periods between pulses. So,
So you reckon I'm not reading it right?
you're reading an average. Yeah.
Peak current probably. Yeah. Or well, I guess most meters average it out. So
Yeah, I was hoping for it would give me an average.
Yeah. But the 600 milliamps is like the peak on a single step. Is that right, Mark?
Yeah, that's right.
Well, the code sets it to 800 milliamps for the pan motor and 1800 milliamps for the tilt motor, but then it ramps it back down. It drops it back down when motion stops. But anyway, I adjusted that and set the pan motor to like an amp, and it started to get quite warm. Too hot to hold my fingers on, and I wondered
So Paul, if you look in the chat, I put the specs for that NEMA 11, a link to it.
Oh, thank you.
And so the NEMA 11 is only rated for 0.67, I think, amps
Okay.
per channel.
Okay.
What's the voltage that it runs on?
12 volts.
I'm running it on 12 volt,
Oh, 12. Okay.
but the driver that we're using basically limits it from current, so you can run it on high voltage, but the current will be limited.
And Mark, is the neck and the motor holding assembly made out of PLA?
PETG.
Oh, PETG. Okay, so it's going to have better heat tolerance than
Right. Yeah, I made it out of PETG so that it could withstand being in the car.
Ah,
If I made it out of PLA, you transporting it in the car in Dallas, it may not have made it.
yeah.
So, Paul, could you take the motor specs and put it in the GitHub? For future?
Yeah.
Yeah.
let me
Offline, but yeah.
Yeah.
I'm
Yes.
pretty sure that's the right one.
Okay, great. Thank you. Okay, only 16 ounce inches. Okay, so I'm going to have one more attempt at joining, and okay, why couldn't it?
Are those like driven by, full step or micro step or?
Yes.
Yeah, we're using the Trinamic 22. I think it's a 2209 driver, and basically it runs. One of the nice things about that driver is it basically drives it at 256 microsteps, no matter how you're driving it.
Oh.
And that's why it can run the motor silently and everything.
Mm-hmm.
It's a common 3D printer driver. It's the driver that they use in most 3D printers.
Yeah, I know in the milling machine setups, if you do, I think it's an F0. F0 is a rapid traverse, and it actually uses like half step, but it's a
Right.
lot noisier, and you can kind of see the handles kind of bounce around.
Yeah.
As it's
So
turning.
the way the Trinamic driver works is it's always running in 256 microsteps, but you actually can put it into like half step or quarter step. And I think we're running quarter step was how Mike was driving it.
I
But
thought
it'll
I put
actually do it by ramping the micro stepping.
yeah. I thought I had the tilt at 16 and the pan at 2.
Okay.
Yeah, and I changed that. I set them both to 2 because
Okay.
I don't think there's really any benefit to microstepping in this, because microstepping is really all about vibration reduction, and there are large enough steps that I didn't think that would make any difference.
Mhm.
Now,
Yeah.
hopefully I can.
It also helps the acceleration if you've got more steps, because it can actually do a finer acceleration.
Yep. Yeah, it's kind of weird. F1 is just a move in the CNC codes, and you could actually get F1 to move as fast as F0, but it did it much quieter. It was much smoother. There was no big steps that it was taking. It was definitely being micro-stepped. So,
Okay, I finally got this.
Well, my 20-year-old printer doesn't have micro stepping.
you're 20. You have a printer that's 20 years old.
Yeah, maybe it's 15, but it's old. Yeah.
So
I bet it does, just probably not high resolution.
So a 3D printer, is that what you're talking about? Or
Yeah, 3D printer.
okay.
so I put
I'd be
some.
surprised if it
What
didn't
one
have
of
some
the, there were some elastic bands inside of here, which were really I think trying to dampen some of the oscillation, and but also to counteract the weight of the electronics and camera in the front. I found that there was 4.2 ounces on the chin. So that was at a radius of 6 inches. There was a fair bit of torque that this tilt stepper had to overcome. So I put in some fishing weights to counterbalance it, and now it's pretty much neutrally balanced, and that enabled me to remove the elastic bands and for it to still move smoothly.
Yeah, that's probably a better solution.
And let's see, so I can hopefully operate.
Roby's no longer lead free though.
Let's see.
Toxic robot.
I soldered with lead. Sorry.
Yeah, so do I. Forget that antimony stuff.
I've still got the Arduino open. Let me just close that. Is that serial port?
Mhm.
And get the UI going. Okay, so so now you can maybe see here that it actually is quite a smooth movement. You can actually kind of perceive it kind of ramping. But there's no, because it's not jerky, because it's not moving so fast, you don't get the oscillation or the resonance in the head.
That's great. Yeah. So I just chose the wrong driver without acceleration. And Mark D was asking, can you turn on an acceleration? Says, I don't see it. So thanks for the new library. Yeah.
Yeah, the Excel stepper is what I almost use exclusively when I'm using the Arduino.
Okay.
So that hit the stop, and it was resonating against the stop is what happened there. But you can actually perceive it accelerating and then decelerating, and you can hear it as well. It sort of gives a little. It's very. It's not losing step.
So should it be doing that, or should it be smooth?
What?
It seems like it's moving in a set number of steps.
Yes.
Well, that's the way it's programmed to move when you send the command.
Yeah. It
So when you
moves
send
and
a command
stops.
like
And then-
right or left, it'll move like 50 steps
Oh,
or
okay.
so many steps.
You're giving it multiple
Yeah,
commands to do
it
that.
moves over, stops, so it can see a clear image.
Yeah. Okay, and then here's the center command. So it goes to the limit, and then.
Okay. But if we have it working better, maybe we can make it continuous. That'd be cool.
Right. That's what I was thinking. Is maybe a good next step, Mike.
Give it a lot more steps.
I don't know why. It seems to me it's not completely bug free yet. Anyway, it needs a little work, but it's operating a lot smoother than it was.
500% better.
Thank you for that assessment, Mike. It makes me feel good because I was like felt kind of bad about changing everything, but then I was like, it just needs it. So I guess for the people on the call who haven't seen Roby, I thought I'd do maybe a little show and tell of Roby's guts. Or has everyone seen it?
Nope, I have not seen close-ups of Roby.
Okay, so Mark made this very fancy NeoPixel display.
Mark R.
Mark
Yeah.
Reynolds behind the screen, so that's pretty cool. And then around the back, this thing is a marvel of woodworking. With like laser cut wooden frames and everything. And there's a fold out tray with an Arduino Mega that controls the body. And so that's a Mega there. There are 4 DC motor drivers, of which only one is used. And it's a 2-channel motor driver that drives the arm lift and rotate. And then there's a DC to DC buck converter and something, or I forget what this thing is. But anyway, there's a bunch of wiring underneath that goes from these wires coming off the Arduino Mega out to these terminal blocks. And from there, they go on off to various connectors. And this is something I think that would be a good improvement, is to make a single connector that goes up into each arm that's got all of these signals on it.
Mm-hmm.
And then the Pi is inside in there.
Yeah, we put a new power supply in there, so it's
Yep. So the power supply is up in there. I can see.
Yeah, no, everything powers off of that as opposed to the 9 or so power supplies that used to be in there.
Wow.
I was gonna say, yeah, that's to
was-
appreciate pictures and appreciate the original view of it.
The cavity was more full.
It was very full. We had the motor for the neck in there. We had a
Yeah.
we had
Yeah.
the extension cord. We had 3 or 4
Bits.
wall warts, a laptop power
Yeah.
supply. What else do we have in there?
And so this thing truly is a masterpiece of carpentry, which is an odd thing for a robot to be, but I'm just going to partially pull the motor out. So the whole motor sort of slides out from side. And inside,
The arm's neat because it uses Cap 10 drives.
yeah. So there's one of the motors, and I don't know if you can make out that there's a line, like a nylon line right there, that runs around the motor capstan. DC, the motor body is down here.
Yeah, instead of a pulley. Yeah.
Yeah, and then it goes into here, and there's a feedback pot for both of these. Both of these motors is one feedback pot you can sort of see back in there. So anyway, that's how it knows where it actually has direct position feedback for the arm tilt, lift and rotate motors.
It seems apt that we put fishing weights in the head if he's got fishing line on the arms.
Just need a hook now.
It's a fisherman's robot.
Yeah. Let's get him a little bucket hat and he'll be off.
Yeah. Yeah.
Some rosy cheeks.
Did I miss anything on improvements that we've made to Roby?
Oh, we switched out the wrist
Oh.
servo.
Oh, the
The
Uno got a pad on it with all the drivers. Yeah.
Oh, we did. Yeah, Mike built the shield for the Arduino in the head.
Oh, yeah, right. So there's a Arduino Uno underneath this shield, and that controls the head, pan, and tilt, and the head
And the eyes.
actually
Yeah.
lift off. And this is a beautiful mechanism. Kudos to
Mark.
the Mark
Yep.
for building it. It's got like the head sort of slots onto this spade, and then down in there you've got the hand servo, and so and so that will like rotate around. Oops. Sorry, I can't hold the head and do all that at the same time. But anyway,
Yeah, so there's two USBs that go to the head, one for the camera and one for the Uno. Yeah. And they connect to the Pi on their USB ports.
Mhm.
anyway, so that's Roby.
Yep. Yep.
He draws attention.
Oh.
Being standing 7 feet tall.
What are we going to do with the ultrasonic sensors?
We
They're
should
not
do-
currently used.
Oh, what do we want to do with it?
I mean,
think
we could.
they
Hook,
were-
I could hook them into the chest nano in the chest, and we could make the chest lights change.
It gets red if you get too close.
Yeah.
Warning.
Not flashing red, like warning,
Oh.
warning. That actually might be pretty good.
If it detected somebody, it would not pan as much. It would just focus in the center.
Just stare at them till they move away.
If it
But
detects
I think
something,
there's-
it can just be in the center instead of panning left and right.
I think there's a fair bit of opportunity for
Yeah.
doing things better with face detection, because I think we could spot a face in the frame and then move directly to the place to center it, rather than step, panning and then step up or down. You could just move directly to it based on where the face was in the frame. So I think that would help.
We also need to figure out how to get the camera to not look through the tinted glass.
Yeah, and so we had a problem. We tried to put a what we thought was a better camera, and turned out it wasn't, because it didn't have grayscale. But that's a green tinted glass, or green tinted acrylic that his eyes are shining through, and the camera is up behind that. And so everything looks green, and a webcam with automatic white balance, which this old one that's in him has, takes care of that, takes the green out, and everything looks pretty much normal. But
And at Moonday, the lighting wasn't that good, and it was real grainy because it just didn't have enough light
Didn't
transmission.
have enough light. Huh.
yeah.
But it still
So-
detected faces.
Well, you could open up the, what is that called? The third chakra, right there.
Mike suggested that, and I sort of like expressed a concern that he's got a kind of a pleasantly impassive look about him, not having like holes and eyes and nostrils and mouth, and well, just like one sort of V-shaped eye. And I thought putting another hole in his face might not be the best thing aesthetically. So anyway, we need help here. I think need some ideas.
How can you cut that plexiglass? The hole wouldn't be as obnoxious then.
Right.
Yeah.
Right.
Oh, we'll just do that on Roby 2. Roby version 2.
Yeah.
Mount the camera in the body,
Yeah.
a little lower, and mount it in the DPRG logo area.
We could do that, but it won't even with a fairly wide angle webcam. I don't think it'll see the width or the angle as great of an angle as it can see looking through the head, which is rotating.
Okay, I was just wondering maybe you could use like a fisheye lens and get a pretty good view. Even if it's distorted, you should be able to detect faces.
Yeah, maybe.
That would be a possibility, and then you would just basically match the head move. Then you'd basically figure out a corresponding head movement.
Yeah.
Since the head wouldn't be doing tracking, the camera position would be fixed. So you'd have to kind of move the head, figure out how to move the head so that it would match the face.
Yeah, without slipping.
Yeah.
Yeah.
You get 120 degrees of motion, 60 degrees either side of from center on the torso,
Mhm.
and with a fixed focus lens, essentially a fisheye.
Okay.
That would interface directly to the Raspberry Pi camera. Maybe a little better than because you can get some quite good cameras that go on the CSI connector on the Raspberry Pi.
Right.
Huh.
So you can get a global shutter, something that'll capture a good clear image even if it's moving.
Well, it wouldn't be moving if it was in the chest. Oh, you're saying the
People could be moving and you still capture a clear picture.
Right.
Instead of a blur as they move.
Yeah.
Yep.
Just my thought on it. You could probably mount it, onto the, I don't know if that's the black plexiglass on the dprg.org emblem on the body, but you could probably drill a hole through for the lens and screw the lens right into there, and it would barely be noticeable.
I was going to say, we have a red bloodhound, and she sheds so much that we have to vacuum every 2 days. We could give the thing like a Trump toupee and put like a little camera like right in the front or something.
Yeah. Yeah. So we could prototype it by just putting a camera, mounting it to the chest.
Yeah.
yeah, that's true.
Because I'm concerned about the pan slipping. And he wouldn't look in the right direction if the stepper motor slips. But Paul said it slips less or doesn't slip at all. So
You'd even use the dog hair to give him, like red chest hair, so.
So the other thing we could do is give him a cap, just a baseball cap or something,
Mhm.
with the camera in it.
Yeah, that's inconspicuous. Maybe borrow a hat from SpongeBob or something.
Or you might be able to put it off to the side in the antenna pod.
That's
You could give him some ears and have it stick out as like an earbud or something.
The dogs outside see my cats through the window. They've never done that before.
Yeah,
That's good
so
work,
anyway,
guys.
there you have Roby.
Thanks for that, Paul.
Mhm.
Excellent work, team.
Yeah, thanks, Paul. That was super.
Yep.
Is that a black star for Roby? Significant progress?
At least.
Well,
We're
something's
giving away
moving in there. That
giving
little
away
red
stars
thing
today,
going back
guys.
and forth. So that's motion.
And he's autonomous.
Yeah, it's autonomous.
Autonomous motion.
Was it autonomous?
Yeah.
That's a gold star.
Yeah, yeah.
Don't start for the club.
All right.
Nice.
Yeah, I mean, this is
He
really
already had a gold for. He already had a gold star for autonomous motion. I
this
gave
has
him that
really
earlier.
been a team effort. You know, I mean, Mark and Mike and Mark have really put in a lot of work into various aspects of it, and it's been a fun club project to bring it back to life and make it better.
There's
And
still a
you
lot more to
modernized
go
it by-
if other people want to jump in.
Yep.
Modernized it by what, 30 years or something?
At least 14. Yeah.
I'd like to help. My commute is too far.
We can mail you parts.
The neck is really a work of art, and you know, hats off to Mark D for that.
Yeah. That saves a lot of space, and
Yes.
that's good.
I'm kind of curious. Did anybody look at you know, like a digital servo? Because those can generate a fair amount of force and they can move pretty quick.
Digital servo, like a bus servo, a serial.
Well, just like I'm not certain what they're called. The next one up from an SR9 or whatever that is, the little
SG9.
SG9.
Yeah, you can get like a 20 kilogram or a 30 kilogram servo.
Yeah. Yeah.
And that would have
I just bought
worked.
a kilogram one.
I
Say
didn't
that
have
again?
any of those on hand. I had the steppers on hand.
Oh, yep.
Yep.
Well, that's good. Does anyone else have something to present tonight?
Well, I can talk for a minute on my slow progress on my transmitter modifications.
Sure. Thanks, Tom.
You may be able to see. Let's see, is it plugged in? Yeah. I
Yeah,
turned off the
characters
backlight
and
on
this is
display. You can see I have things displaying now. I've
Oh, wow.
I mean, this is pretty simple stuff. It's just code I've used in other projects before. That's why I'm still using these old LCDs. I've got a bunch of them. So anyway, I thought I would mention a couple of the interesting debug discoveries as I'm attempting to make this work. I decided to use an analog multiplexer because this ESP 8266 only has one analog input. So I used a 4051, operated it at 5 volts to provide multiplexed analog inputs. Very, very lovely little board, which you may be able to see sitting way down deep in here. Has all the analog stuff on it, the multiplexer, and all the interface wiring that's analog. And it's got a couple of bolts to hold it on the back side of this lovely workable plastic transmitter box. And I thought, plastic's an insulator. This should be no problem. So I didn't get really excited about putting standoffs in it or anything. So it's just kind of stuck against the back of the plastic. And I had a hell of a time. Nothing would work. Finally, in the course of fiddling with it apart on my workbench, I discovered that just by pushing different places on the analog board, pushing it down against the plastic base that it's on, things would work or things would not work. So just for the hell of it, I put an ohm meter on this plastic box. The damn thing's a conductor. I've never seen conductive plastic before.
Oh, is it like painted with conductive paint or?
I thought it was painted, but it's not. The plastic
yeah.
itself must be impregnated when they made it 60 years ago with something to make it conductive so that it forms an RF shield, because there was a 27 megahertz oscillator inside.
Yep.
I was just flabbergasted.
Yeah.
Wow.
So I then had to go through and insulate everything where I had circuits mounted on the plastic.
So how conductive was it? Tom?
If you put an ohmmeter probe from one side to the other, either on the outside or the inside or both, you're down around 1 or 2 ohms.
Whoa,
Conductive.
That's good.
I've never seen
wow,
So
that's
You have,
crazy.
you have a ground bus bar. Yeah.
a ground plastic box. Yeah,
Wow.
I was really surprised. I thought it would be conductive paint, but it's not. There's no paint on this. It's the plastic itself that's conductive.
Don't make them
Yeah,
run
that was a
easy.
surprise.
No.
The only other fun part was I used several 2N7000s MOSFET transistors as level converters to convert between the 3.3 volt output of the ESP and the 5 volt inputs on the 4051 analog multiplexer. That's a fairly simple thing to do. It's easy to wire up. Trouble is, I go to my handy browser and I Google the pinout for the 2N7000s, and Gemini gave me the wrong pinout. So I wired 3 transistors up with the wrong pinout and then wondered why the hell the outputs didn't work. Took a while to find that one too. That's when you start double checking everything you've done. But it's coming along.
Yeah. Well, I can show my my outdoor robot taken apart.
Yeah.
Sort of like a Roby. I'll just move my computer. So here's my mess right here. Yeah, so you can see, like, this is the chassis, of course, with the motors and the batteries. And then this is the circuit. This is the circuits on a board, and that'll mount inside this. Trying to look on here. Like, there's this. You can sort of see from this angle that it's a Jeep body here. So I put it upside down and screw it on, and then screw it onto and then put it onto the chassis. So, and then this is my. We're gonna put my reset switch. I don't know if you can see it. Yeah, right there. Yeah.
Yeah.
So it's plugged into the side of next to the power cable. Now I'll put like I have the external power right here, and so I'll put a switch above it or something to turn it on and off.
Mhm.
So that's I'm still working on just putting the body together and electronic. Good stuff like that.
Mike, do you know how fast it goes in miles per hour?
No.
No.
I mean, I can go. I mean, it can go really fast, but I wouldn't be able to control it with ROS. It can go. It can go pretty fast.
Yeah.
Probably 5 meters per second or something like that.
Yeah.
And I can control it up to a half or maybe 1. So,
Mhm. Yeah.
but if I just use it without ROS or anything, just with a remote control that comes with the car, because that still works. It can zip. It goes
Mhm.
zip. Especially in high gear. So it has a gear, like a high and a low for a gear.
Hmm.
Yeah,
Yeah.
for the computer control is always in low gear and goes slow.
The hoverboard motors at I was trying to set it for, like, I just did Googled it, and it said the average walking speed for someone with a push mower is like 3 miles an hour.
Mhm.
And that's only at like I think with a PWM value of 75 out of 255. So the thing will go quite a bit faster, but then it's a thing of I'm not going to be able to chase a platform going 6 miles, even 6 miles an hour up the hill to at Steve's place. Is just wait, I'll be there in a minute.
That's what the kill switch is for. Remote kill
Yeah.
switch.
I don't know. I mean, 3 miles an hour. I'm not saying you're capable there, Ray. But you got the gray hair. I got the no hair. 3 miles an hour walking for very long at all is it's not. I can't say it's an incredible feat, but it ain't slocking around. It ain't sloshing around.
No.
It ain't moseying. I'll tell you that.
Yeah. Oh yeah, I think it'll easily do 6, but I don't know if it's controllable at 6 miles an hour.
Also, Tom, your radio, your unit, you're doing that. Is that from not Futaba? They came in red, and they were back in like 1972, and I had a red version of that. I know exactly. Well, mine was all red, but I had the same gimbals and the same setup and the whole thing back when I was trying to fly some RCs back when I was much younger than I am now.
The only identification I have on the radio system is what it says there on the front. It's a Space Commander. And the fact that the printed circuit board has printed in its copper layer, it has Japan Micro. That's all I know about it.
Actually, there was an article in Academy of Model Aeronautics not too long ago on the history of RC controllers, and I remember them listing that one.
Okay.
Maybe I can find a note and send it your way.
Maybe you can send me any other details, Carl. I'd like to know. I know I bought it in 75 and it was used then, so it's older than that.
I'll see what I can find.
Thank you.
It was first one with conductive case.
But I have a theory on that, because there was a time when you just made stuff out of metal because we knew how to do that. But these days, I mean, metal does conduct and it shorts stuff out. So I think there's a reason why lots of, like, think of your power drills, your power tools. They're plastic. I mean, they're more, in a way, they're more durable. They don't have the conductive short out problem. So I think there's something there.
Yeah, well, this plastic was very easy to work with. I did all the cutouts and drilling to mount all the extra stuff I added. And I mean, it's really nice workable plastic. But my God, conductive, I've never seen that before. It makes sense for an RF shield, but I don't know how they do it.
I know they used to, in some plastics, they'd put carbon inside it.
Yeah, that's what I was going to say. Yeah.
Yeah, I mean, there's like when I did EMC issues for military products back when TI still had, Texas Instruments still had them, there was a whole bunch of conductive rubbers and elastomers and paints and things. And I mean, they might have silver impregnated in them or other kinds of conductive materials, but absolutely.
Yeah. So this may have more value than I thought.
Well, you're hacking on you're making a current update to a cool item. That's for sure.
Maybe it's gold impregnated.
Could be.
I remember when gold was just how much an ounce, right?
It's probably some type of metal, because if you're only getting 1 ohm across it, if it was really carbon, you wouldn't be getting 1 ohm.
Yeah, I was astonished when I saw that. I couldn't. Well, I believe it, but because I took the measurements, but it was really surprising. And it's everywhere. It's all of the plastic. And
is it even like when because you modified it, you drilled holes and openings, right? Did you try, when you drilled through, did you try the inside, like the via of the hole, instead of the surface, the outer surface? Did you try plastic to plastic? And with like, if this is the thickness, did you try from here to there?
I did not, Carl. I understand the point you're making. When I drilled this stuff, I don't see any differentiation between the surface and the interior of the pieces, but I don't think I have anything exposed that I can touch on the inner edge of any of the cuts I made. They're all tend to be covered up. Good point. I wonder if I can get at anything. No.
Just go ahead, make another hole, put a switch.
I'm already multiplexing all the switches, and I'm in the process of calibrating the analog inputs that I multiplexed. So I'm not adding anymore. It's like, gee, I could use 2 or 3 extra switches, so let's add 6. I'll find a use for them.
Well, thanks for the update. That's interesting that the plastic is conductive.
Yep. Like I say, the circuit board. Oh, it's young enough that the transistors on the board are silicon. They're not germanium. Does that help with dating it?
Well, it wasn't from the 50s. Yes.
I tried to reverse engineer the board because I initially thought I would just use the joystick encoder circuitry that's in here because it's supposed to be fairly basic according to the half a dozen typical designs I looked at. But when I started to reverse engineer this thing, it became clear that this is not the same as all of the other encoder circuits of this vintage that I have schematics for already. So I stopped. I went ahead and used analog inputs.
Yeah, I found I've looked all over for these when I purchased them. They're replacements, I think, for I want to say Fly Sky. I don't know if that's it or not. It's been so long, but one of them has the up down axis has a return to 0 spring.
Yes.
And the other axis doesn't.
Yeah.
So you can set like I'm assuming a throttle or something like that with that one.
That looks pretty robust. That looks like a good one.
Yeah, I think the little thumb joystick ones, those they'll end up all over the place for, like a return to center. And these ones, they seem to have a much longer throw than the other ones did, the little thumb joysticks. And I think the thumb joysticks, if you move it like 3/8 of an inch, you're going from center to, one extreme.
Right.
Whereas, these, it's quite a bit more movement on the stick. And that one's got spring returns to the, in both directions, both axes. So
Ray, are you saying that you're having trouble with the little joysticks that any 4-year-old or 3-year-old that mastered?
yeah, not enough throw on it. It's like just a little bit of movement. And I never got into video games, so
I used the little tiny thumb joysticks to build a manual controller for a Heathkit robot back several years ago. Yeah. And I had to be so careful working with them because they're really delicate.
Yep, very really coarse kind of adjustments. Like like I said, going from here to there is full scale. Well, from center, middle of the scale to full scale.
Yeah, exactly. That's what I used.
Yeah,
they work, but carefully. I wouldn't want to drop it on the floor.
Nope.
I had tested them to use on a robot, and I had them in a RC transmitter already, or a game, a Bluetooth. And like you say, the throw is wild. You're moving it, and it goes quite far. All I did is I mapped it and scaled it back so that it was way less sensitive. So I wouldn't allow it to go maximum.
Yeah, I think I told you guys before. I had there's a 3-position switch, and if I throw it in one of the positions, it makes the center code 127. So it is, centered, I guess, electrically and mechanically. And of course, you have to throw out a few counts on either end, depending on where it was on the, above 127 or below 127. But because that's just letting the 2 joysticks go without doing that, the thing would like slowly creep away. That's kind of like, nope, stay still. But anyway, never put them on anything. So But there they are. Yeah, and you'd think, higher end control units, they'd have, I don't know, maybe they don't replace them, but you'd think they should offer a replacement for controls, because I'm assuming that's what wears out more than anything. But there didn't seem to be very many in AliExpress at all.
Yeah, probably depends upon how much you paid for the original radio control system and whether they're still using that technology. A lot of the guys in the model airplane club I used to belong to loved Spectrum radio systems. And they're really, really nice. And you can buy replacement parts for everything inside. But my God, are they expensive? You can easily spend $1,000 on an aircraft radio control system from Spectrum. They're really pricey. I never bought one. I stick with FlySky.
Can I unpin myself?
There you go.
Okay. Does anyone else have something they'd like to talk about or discuss?
Yeah, I'll mention one more thing. The feeds I normally get for things like humanoid robots are becoming very, very ordinary. Many people are making thousands of humanoid robots these days and applying them in all kinds of situations. But yesterday in my feed, I got a notice about a Centaur robot in the interesting engineering thread. Anybody see that one?
Mm-mm.
Yeah, that's the first Centaur robot I've seen. A humanoid upper body and a four-legged lower body.
Oh, okay.
Wow.
Stands as high as a human. It's almost 6 feet high. So 3 feet long in the body and 2 feet wide. It's got wheeled legs. So 4 legs that also have wheels on them. So it can walk as well as roll. Top speed of 20 miles an hour. A static lift capacity of 200 kilograms, according to their marketing literature.
Whoa.
Intended for very difficult environments, very rough industrial environments. No price. They've just showing their prototype so far. But a Centaur robot. Humanoids, old news now.
Wow.
Well, I thought that's why they put wheels on the Unitree robots. I thought it was easier to do certain maneuvers for, if you had wheels on your feet, I guess.
What I've read is they put the wheels on.
It's easier and it's
Go a
also a
lot
lot more
faster.
energy efficient.
It can go a lot faster with wheels than it can walking.
Mm-hmm.
But the wheels make it hard to go upstairs.
Yeah, it's probably one of those things. If you ask how much it costs, you can't afford it. So,
But give it a year or two, and everybody will have one.
yep.
As soon as they decide that it's a good idea.
I'm gonna have to wait around for the robot junkyard. I think that's where I'm gonna have to get my parts. I think so.
Yep.
Anyone else have something, guys?
God, I think it was called Modulino. It was basically I2C muxes. It's like 3 different boards. One was an I2C mux. One was an extender. You could go like I don't know. I think they said I want to say 30 feet, or was it 30 meters? No, I think it was 30 meters. With an I2C line. There was a third one. I can't think what it was now, but I doubt any of the robots. You could have an extender, but you probably wouldn't need 30 meters. So I'll see if I can find it.
And while Ray's looking, here's the image that Tom was talking about.
Yes, that's it.
So that's what our overlords are going to look like.
He looks pretty badass.
Okay.
Yeah.
Huh.
Wow.
It's apparently explosion proof as well.
Yike.
You can use it in explosive atmospheres.
Interesting.
Arduino I2C extender.
Arduino I2C extenders expand either the number of pins or the distance of your I2C.
Yeah, it's called Modulino. Modulino. Let's see if I can get something here. Yeah. Let's see. Nope, that's not it.
Oh, a line of plug and play smart sensor and actuator modules.
Yep. Oh yeah, that's right. They had a motor driver was one of the modules.
All using I2C protocol to daisy chain everything together.
Yeah. Yeah, I don't see any pictures of them. Kit, Modulino. Yeah, there it is. Okay.
So that would suggest with an I2C interface that it's not specific to any particular CPU environment.
Yep.
As long as you can run a driver over I2C, you can control it.
Yeah. Where is it here? Anyway, was that, let's see, motors, extender. Yeah, it doesn't say it there. Ammo. Yeah, I don't see the distance in it, but I thought it was like 30 meters, a lot longer than most of us would need. But,
Well, while Ray's looking, I just want to remind everyone that about the monthly meeting on Saturday, and it's a show and tell. So if you got a robot to show, bring it. Show it off.
Yeah.
There's no
So-
speaker, Paul, this time.
No speaker this time.
So it's just a lunch, pizza lunch, and so show and tell. Bring a robot, trade your stuff.
Bring any parts that you want to give away or think
Yep.
other people might be interested in. Swap meet / show and tell. Maybe give a little 10-minute talk on what your robot is. If you feel like it, or if you don't, then don't.
So
anyway,
I'm
those are
assuming
the three, the
well-
extender, the motor driver, and the hub that I saw information on. So, and I think you can daisy chain a bunch of hubs because each hub has an address, and then you can chain them.
Cool.
I don't know. Yeah. 8 additional I2C addresses. Of course, you got to click on each one to find out, and I can't do that from here. But anyway, look kind of interesting. The prices seem reasonable for what it was. And anyway, yeah, that was one thing that I saw.
Hey,
So I did have
Tom,
something.
hey, can you hold up that, I was gonna ask you to send a picture, but I figured I can actually just do a screenshot. I found some candidate of the articles, but I can't find quite the right one. So let's see, could you kind of center it there? That's good. And then hold it still just a moment. And I'll get a screenshot
Say
and then I'll do the,
cheese.
because you got me on a roll now, because I'm really wondering if I can get a GPT to find this for me.
It's really cool.
Okay.
We'll see.
Yeah.
I'm not going to hold everyone online to do it now, but I'm on a, you can put it down now. Thanks. I'm on a roll to give it a shot though, for sure.
Want to get that too?
Yeah,
It's just
that
the back
one's
of the
not,
circuit board that was in it.
yeah, that's
No,
not as,
huh?
not as distinctive, I think.
Okay, I didn't think so. There's not much on
Yeah.
it. It has a part number on the back called a TX-505 Mark 1, MK1.
Huh.
Yeah, looked like an
Still
old
meaning
transistor
anything when I
radio
prove it.
board.
It'll
Oh,
be
so it's a British, but you got the G55, not the G45. Okay.
correct for what it's worth.
All right. Good.
And it's
All right.
a 6-channel. It was a 6-channel transmitter. They configured 5 channels.
Okay. Well, I'm on the hunt now. This is
27 megahertz.
I love a good challenge.
Mhm. Yeah, so I did have something that I totally forgot about until just now. But yeah, I picked up the DF robot, the Lidar, the 64x8 that we were talking about a while ago.
Oh,
It finally came in. It was on back order,
Oh yeah.
Oh, cool. You got it.
and
Huh?
it finally came in. So I had a little play with it last week. Yeah, last weekend to try and get it working. And I have some really poorly. Well, no, it works, but it's me and AI's best attempt. Let me see if I can share screen. Try screen. That one. I apologize. I'll have to zoom in a little bit because this is a 4K monitor. So I'm not going to go through the code or anything because it's boring. But let me get the thing running at least. I'll kind of show you what I've got so far. It's not very fast. Oh, it's on the other screen, of course. I'm using Open3D to do the point cloud. So that's kind of what you're looking at with the whole 64 wide and 8 tall pixels. And you can, I'm pointing it directly in my monitor right now, so it should have a fairly flat background. But if I tilt it, you can still kind of see the flat background. And then if I stick my hand on the right, you can kind of see it.
Mhm.
Like it's
Yeah. Huh.
let me see if I can filter it some more. I put a little filter on it so like it would slow down with the dots jumping so much. And that kind of helps a lot. But yeah, so there's my hand on the right. And kind of like giving a
So is the height of the dot the distance?
yeah.
Or the
Well,
color?
I think it's literally like as far as like this blue on the left here is my hand that's holding the sensor.
Hmm.
And so if I put my hand between the screen and the origin point in the center,
oh, so it really is a point cloud.
yeah.
Wow.
So you're kind of looking down at it, so
Okay. So yeah.
right off to the right, or off to the left.
Cool.
Proximity to the center, huh?
Yeah, it's pretty cool. It's supposed to get like 8 frames a second, so I got to play with the software and tweak it. I'm pretty sure it doesn't do 8 frames a second in Python, but I'll find out.
Hmm.
I'm gonna have to switch to C++ or something to do that speed, but yeah, it's pretty fun so far.
That is impressive.
Yeah.
Fun little sensor.
That's cool.
I was skimming through an article last week that was talking about the technical developments in moving from mechanical LiDAR to solid state LiDAR. But the article was focusing on developments in how to build LiDAR arrays that are analogous to fixed electronically sweepable radar antenna arrays.
Oh yeah.
Using steerable lasers instead. Amazing stuff. I don't pretend to understand it all, but I was really amazed. That's different from what you've just shown, Mark, of course. Yours is simply an array of lasers or LEDs. This is basically picking a set of linear, it looked like linear lasers could be electronically steered. And would have never thought of that. It's an intriguing concept.
Oh, kind of like phased array radars.
Precisely. That's exactly what they're trying to do.
Yep.
Yeah. And of course, they're not trying to do it at the hobby scale. They're trying to do it for military purposes, I'm sure.
Yeah, this was a good price. I think it's like $45. I think this one was. Pretty good price.
I just posted a link I got from Ed this week on a LiDAR scanner that a guy pieced together.
Oh, yeah.
It was interesting. Basically, doing a 3D scan, high speed, using parts he got off of eBay and a motor that he had designed himself. Like not a motor, but a motor controller to give him the 360-degree scan.
Did you see what Kareem showed a couple of weeks ago? I think it was. He had a 3D LiDAR. It looked like
similar to what he had.
Yeah.
So if you play the link, I won't play it now, but if you play the link, it's very similar to what Kareem had showed us.
Okay.
Yeah.
And
I saw that when it came across my feed too, and that's really pretty nice. He bought that. That's a 16 LiDAR, 16 beam Velodyne puck with the beams arrayed plus and minus 30 degrees. That he's, normally it would see 360 degrees around you, plus and minus 30 degrees. But since he's rotating the thing, he can turn it into a like 360 degrees all around you thing. And he bought it used. So new, I think they're 8 or 16,000, something like that. He got it for 400. So I looked on eBay, and in fact, you can buy those 16 LiDAR pucks on eBay for about $300 or $400. Used, obviously.
yeah, well, it was an interesting video, and it goes through what he's done, how he managed to modify not so much the puck, but the holder of the puck to create the 360-degree scanning, and his timing and the IMU and the whole works to go with it. It looked like it did a pretty good job of giving you a real world 3D map, and quickly.
And then he put an IMU on it to tell where he was, so that he could essentially use SLAM to build up a world, a point cloud of the world around him. It was pretty cool.
Definitely. I just look at that, and I got a 2D LiDAR, and you try to eliminate noise in a 2D LiDAR, and he's got a 360 degree by 360 degree LiDAR. There's a lot of noise. If you're trying to detect, an object, there's a lot of stuff there to filter through to try to find what you're looking for. He did send me another link, but I couldn't get it to work. It wouldn't open.
Okay, I have a follow-up on the Tom Crawford history of RC controllers question. So I'll put this in the other I'll send it out later. But anyhow, I found several articles. This is the one that I was thinking of, but it was a different, like there was a certain era for these things, wasn't there?
Yeah.
For RC controllers. And one of their places in here, this guy, I think, where is it? Control Air. One of the, they're kind of related because a bunch of these guys just moved around and did their own little thing after a while. So, like this one, that was the 2021 article. This one, 2026. Well, that's the one I just showed. I'm rambling on you now.
Have you ever seen the old RC controllers? They use vacuum tubes, and the control surface used to move back and forth.
Yeah, they were pulsar.
Pulse, yeah, till you gave it a control, and it would go one way.
Yeah, I remember the name of the brand I had that looked about like that. It was called EK Logic Troll. EK
That was the red radios.
What now?
That was the red RC radios. I remember those when I first got into it. Some guys had them in the early 80s, late 70s.
We got it used because we're in the RC club with my dad, and he found one used, and we had this thing, and it was ancient old and the round silver stuff. The later ones had a black square face on it, but the older ones had. I had one for many years in the attic. I think I sold it for like $20 to some collector out in Arizona or something. I said, as is, have a nice day, because no telling, there's no batteries. It's now, because they've changed the FCC regulations where it comes to all those radios, they're all illegal to use, pretty much.
Yeah, here's one from December 19, built from plans in the December of 1940 Air Trails magazine.
Oh, look at that.
Oh, God.
Yeah, there you go. And then here's, I built one from this brand. It didn't look quite like this. It was more after that, I think. But Mattel, yeah, there's.
And I think you folks are right. If I remember correctly, they used pulse things instead of this, the analog. It was all analog. There was no digital stuff. I remember the digital stuff coming in and everybody raving about it, right?
Well, they were bang bang.
Yeah,
literally they could only they oscillated between positions, and all you could change was how much time did it spend one way or the other.
Yeah.
So
I remember seeing them. They had little tiny vacuum tubes in the receiver.
Yeah.
If I remember, they were like 3/8 of an inch in diameter and about an inch or so long, with a bunch of wire pins coming off the one end. There was a couple of those in the little transmitter.
Yeah. Okay, and then here's a real-time research thread for you, Tom. Just check the chat window there.
Okay.
But that's all I got for you. I remembered wrong, but gotta feel good about on the spot for that. It gives you some dates too. All right, that's all I got.
Okay. G45. Good. Thank you. I'll follow up on that some more.
Yeah.
The reason I have quite a file on ancient radio control systems, ancient from the mid-70s, is because when my first work assignment, I got assigned to a project that meant I had to go on site at a General Electric facility here in Canada and spent a year and a half working with General Electric engineers who were radio controlled model hobbyists. And they were all designing and building their own complete radio control systems. Everything designed from scratch and all digital. This is 74, 75. So I joined that group, never built one, finally gave up and bought one. But it was fun. I learned a lot.
Oh, it is fun.
Okay, there was a guy, I don't know his name was, or his place was called Magic Mike. He was on I-35. They did the expansion on I-35 and it went right through his facility.
Mike's Hobby Shop.
Mike's Hobby Shop. Okay.
Yeah.
Anyway,
He finally got $2 million for the property to slice in half for the road. He held
Yeah.
out for a long time. That's why it was so run down towards the end.
Yep. Yep.
I mean,
Anyway.
that was a fantastic place, man. That
It was awesome.
fantastic.
Apparently, God, he was talking to, what's his name? God, it works for SMU.
Oh,
God.
Dave.
David Anderson.
David Anderson, yeah. And you know, David asked him, you know, who buys the, you know, most of the stuff, and he said it was single men with a lot of disposable income. So he was more than glad to sell it to them.
Men and boys, price of their toys, sort of thing, right?
Yep. Yeah, I remember that. Single men with a lot of income.
Okay, but Paul, thanks for fixing Roby.
Hey, it was fun, Mike. It really was. It was a little bit of a challenge, but I figured I'd bring Roby along on Saturday for the show and tell, and you know, he can do his thing, and everyone can look at him.
We're going to put it back on the shelf.
Well, you know, we need to talk about that. I think, you know, you, me, Mark, and Mark ought to talk about, you know, do we want to do anything more? What should we do? I mean, he needs to move out of my house, which means he needs to move back to the makerspace, probably to the animatronics lab. Hopefully, if Mark will accept him.
Yeah, I kept his spot. He's good.
He's a well-behaved bot now, but yeah, we need to talk about what we want to do next, whether we want to have more Roby work days, whatever.
Oh yeah.
I'm enjoying my Moonday
Yay.
mouse pad.
Those were fun.
All that kind of stuff. So that's what I've been doing. Oh, and the other thing is, Doug's not here, but today he sent me a note about some of the M5 stack stuff. There's a seminar sort of thing going on with DigiKey on August 10th or 11th. And you know, he knows I've been playing with these balance bots, and they've got a couple of M5 stack based balance bots that came out. That DigiKey selling, and the seminar is based on that. And I ordered both of those today just because I'm not that smart of a fellow, and it sucked me in. And we will see what happens on those things. And so my thing is, I'm looking at balance bots all over the place, and I've been trying, and I'm a little sad because I need to talk to Anderson actually, because I was talking to Doug on Saturday about this. I need to talk to Mr. Anderson about this stuff, because every one of these things I find online, when I actually get to the end of the video, after they tell me all the things they've done and all the stuff they've done, guess what? They ain't doing no better than I'm doing. And that's every one of them I find. And I'm like, okay, so either we're all missing something, or we all don't want to pay a whole bunch of money for some IMUs that would give us enough stuff and motors to do the Boston Dynamics kind of thing where you can stand on just two wheels and just go straight up and just stay there. Apparently, Mr. Anderson was able to do that with his two-wheel bot, and he did a pretty good job of it. And I don't think I've ever seen that bot, but I have heard about it. So,
yeah,
if I remember, his was it encoders or motors? But his encoders had some ridiculous precision, like I don't know, 3,600 DPI or
right?
Yeah, it was an insane feedback resolution.
And that's probably where success and failure comes in with some of this stuff. Just because it doesn't take very much, you know, you get that tipping point thing going on, right? And it doesn't take but just a rounding error to get it going. And if you don't have stuff to compensate for it, it runs away, and next thing you go, you got laying on its face.
somewhere if you search, I think DPRG clips, he did, excuse me, he did a talk on that, and I remember him discussing a way to figure out where he could pretty much get his little two-wheel guy, he could get it to stand up. He had enough torque, and he could figure out if it's leaning too far. He could speed it up to roll it. So he had, I think, a pretty dynamic control loop in there, and enough torque to do crazy things with it.
Oh, I wonder if Dave
And
knows
resolution.
my friend Ian.
Hmm.
He was in the geology department at SMU as well.
Yeah, probably.
Ian's a pretty funny guy. He's a magician. I know him through the Magic Club. Pretty funny guy. I don't think so.
Anyone else got some robotics related stuff to talk about?
Yeah, see, there you go.
Yeah, yeah. Getting back to what this is all about.
Okay, guys. I guess we're going to call it a night. I'm assuming we're not going to be recording the Saturday meeting.
What meet?
Probably not.
Show and tell.
Yeah, doesn't seem like it's the right kind of content for that.
Mm-hmm.
Yeah, that's what I thought.
Do like a couple hours of like elevator music or something.
Okay, guys. Well, we will see you on Tuesday next week.
Okay. Thank you.
Great.